Next one up, we have another really wonderful, I guess, funder in the larger space. In fact, you've heard yesterday from two FROs that he was really instrumental in helping get started, including E11 and Forest Neuro. And I'm really excited to welcome Adam to the front. I remember when you gave a talk on the concept of FROs a few years ago. And a few years later, here we are. The first FROs are not only existing, but also have produced some fantastic results, as we've heard yesterday. So congrats for that. And I'm sure that you have more ideas for the future.
Thanks so much. Awesome to be here. Thanks so much. So I run a nonprofit called Convergent Research that is pursuing this particular approach around focused research organizations, which I'll tell you about. Is this the right?
It is the right. Maybe you should. Maybe it's better if you do it right on the screen.
So the inspiration that we take at Convergent is from, roughly speaking, these types of projects that I'm showing on the screen. So the Hubble Space Telescope, the Human Genome Project, the giant super collider under the city of Geneva with CERN. And I think these are broadly agreed to be really important part of science, right? These are big engineering in support of science. But importantly, they're not scientific discoveries in and of themselves, right? These are not creative insights that one scientist had. These are infrastructure, really. They're scientific infrastructure. And the type of work that's involved in building that infrastructure looks very different than sort of discovery-based science, where maybe a brilliant grad student has a new idea based on years of apprenticeship to their professor, right? This is many people working together, division of labor, building stuff. But they also don't look like startups, right? This is not serving a market need. These are serving bottlenecks in science, things that the scientific community needs in order to build. And so I think this is not every focused research organization necessarily builds scientific infrastructure, but this category of scientific infrastructure is kind of important to think about, kind of in relation to what Kate said of like, what are these things that the market doesn't do well, for example. But all of these are multi-decadal, international, government-backed mega projects, right? These are kind of, maybe you have one or two of these a decade or something like that. And so our question really is like, how can we make more of these? Maybe there's not just a few of these, maybe there's hundreds of things of this category, big engineering in support of science. Maybe there's a few hundred that need to be done. And if you prioritize that, you know, there's certainly dozens. And they're fields that we believe are really bottlenecked by the lack of strong ways of building these. So what will it take to make more of these, make this more accessible to more good ideas, and solving more scientific bottlenecks? And we don't think that this is a problem that there's a lack of money in the world or even of capital that could be allocated to this, right? So these are all these multi-billion-dollar projects. But what we see, and this is related to this question about how DeepMind solved protein folding, solved, we'll put in quotes, but transformed the field of protein folding with their AlphaFold project. It's not necessarily that you need thousands of people and billions of dollars to build key scientific infrastructure. You might need 20, 30 people, 5 to 10 years, coordinated, looking more like a Series A level deep tech startup type effort to build some of the key tools, systems, or data sets that are needed to advance progress in these key fields of science. But even that by itself is really hard to organize. So Mohammed Al-Qarishi, who's a professor at Columbia who works in the field of protein folding, is a big leader in that field. Kind of from the outside, from some loose affiliation with that team, observed the following thing about the AlphaFold team in DeepMind that made so much progress. I think they're in Stockholm right now, receiving the Nobel Prize only like 5 years after starting this work. Basically, they said the AlphaFold team is organized very differently from academic groups. The research is done by professionals. Everyone is rowing in the same direction. The AlphaFold 2 abstract has 18 co-first authors and is reflective of an incentive structure wholly foreign to academia. So this is from an academic professor who works in protein folding, saying about what is the difference in terms of how that team was organized. So these are fast and focused strike teams, and so that's what the focused research organization model is inspired by. How can we build more of those for problems that need that? And I'll just give you another example. This is now another Nobel Prize winner who hasn't had a strike team or focused research organization funded, Eric Betzig. He wrote up a paper, a proposal last year on a cell observatory to understand how cells, the kind of dynamics of cells in tissues. Can you image subcellularly in the context of intact tissue with live cells? Which kind of seems like a very fundamental thing to be able to do in biology, right? You want to know how the cancer cells are moving around and migrating, how the immune cells are attacking them, how the organism is developing. It's a very fundamental capability is to build a kind of 3D video microscope of cells that can see both subcellularly and over like large distances, right? Very fundamental basic capability. Eric Betzig knows how to do it. He's got the Nobel Prize, senior, HHMI, lots of funding. He cannot, in any of the existing structures, get a focused research organization funded. That's a Nobel Prize winner. So now imagine that you're just like some person with an idea. It's really hard to do. So if you think about the things that are missing for this video foundation model beyond like what he can do right now, part of it is like he needs compute, right? So he says I need 13 NVIDIA DGX, GPU pods, bunch of storage, but like those are very doable things. But fundamentally, they need this professionalized startup like non-academic but research heavy organization that can engineer this observatory and build that foundation model. And this is a Nobel Prize winner, right? So I think it stands to reason that if you look across fields, there's dozens of these types of bottlenecks that are really important. This is this text right here. It's a little hard to read, but this is like from his paper. He has a talk online too, but it's kind of this is my summary basically. Difficult to achieve in academia where single-minded focus is rarely possible. Resources often constrained, staff turnover is higher, et cetera, et cetera, et cetera. This is not to bash academia. I think academia is like the lifeblood of where many new ideas come from, like very fundamental. Academia can do things that other institutions fundamentally cannot either, like kind of mind transfer from, in the process of doing a PhD from very deep fields, right? But this type of infrastructure building gap, I think, is really large. So we are trying to solve this with a kind of template or rubric that is understandable both by philanthropists and by scientists, with this focused research organization. So these are finite duration projects, but they all have, it's not that they just die afterwards, it's related to this idea of retiring risk. But it's not necessarily just retiring market risk, it might be retiring the risk to work with a larger institute or a government funder or merge into a larger institute, spin off a longer lived nonprofit, or to spin off companies. But you're 5 to 7 years focused strike team to retire that risk with a leadership model that looks a lot like a deep tech startup, just for a nonprofit purpose. And just really quickly, our nonprofit basically tries to make the probability of there are many things that have to come together for a FRO to be built: funding, people, research roadmap, legal and operational infrastructure, and we try to bring all of that together in a repeatable way. And so just really quickly, you guys saw yesterday, E11 Bio is one of our first ones that's making trying to make 100 times cheaper connectomic circuit mapping using optical microscopes. A couple other projects. Neuroscience is kind of part of where we started. It turns out this also needed even other fields you might not think, like math, right? Mathematicians, lots of creative ideas, but they're not necessarily professional software engineers to build their own software. So we have one in software for math that then turns out to also be important for underpinning the use of AI in math. We have one in understanding the off-target effects of drugs as well. And so overall, I think that it's hard to say exactly how many fields of science there are. It's very approximate, but imagine neuroscience, material science, chemical engineering. Just imagine, like, say 20, 30 important fields of science. There might not be thousands of FROs that you need, but in each of those fields, there might be, say, 3 to 5 key pivotal pieces of scientific infrastructure that can't be built in the existing system. Each of those costs, say, $20 million, $30 million. That's a few $1 billion. I think if we could find a way to spend that few $1 billion as a society, that would unlock trillions in value. So thanks a lot.
We have time for a question.
Hi, thanks, Adam. That was really inspiring. How do we map where FROs should be born?
Yeah, I mean, what's funny is this is very related to, I think there's also, I think Tom is going to talk about this, but basically there is both a implementation gap, like how do you get the funding, how do you get the team, how do you start the nonprofit, et cetera, to do these types of things. There is also a agenda setting or road mapping gap. What are these key bottlenecks? what would be the actionable plans. And basically the key observation, maybe the most exciting thing I think about what we've done so far is by creating more of a path to the funding and the implementation, you start to elicit more. People don't have a reason to actually spend the time road mapping an FRO if there's no way of getting that funded. On the other hand, philanthropists has no idea what the good FROs are if there's no roadmaps. And so to me, the road mapping is actually the fundamental activity. That's actually the most important thing, is the agenda setting and figuring out what these bottlenecks and how you solve them. But without getting the flywheel going of showing you can actually build these and get the funding, nobody spends time thinking about it. So that's what we're trying to solve, yeah.
Thank you so much, Adam. Awesome. Thanks.